Imagine waking up one morning and discovering that every volcano on Earth has become active at exactly the same time. Thousands of volcanoes scattered across continents and beneath the oceans suddenly begin releasing heat, ash, lava, and enormous amounts of volcanic gas. At first, the most obvious danger would be local. Communities near volcanoes would face ashfall, lava flows, toxic gases, landslides, and powerful explosions. But the real global consequences wouldn't come from every volcano sending lava across the planet. Most lava flows would remain relatively local. The much bigger problem would be what these eruptions put into the atmosphere. Massive quantities of ash and gases would begin rising above the Earth's surface, and as thousands of volcanic plumes grow at the same time, the atmosphere itself would begin changing. As the eruptions continue, the atmosphere becomes the main battlefield. Volcanic ash can spread over huge areas, but ash doesn't necessarily remain in the atmosphere for years. The bigger concern is sulfur dioxide. When large amounts of sulfur dioxide reach the upper atmosphere, chemical reactions can produce tiny sulfate aerosols. These particles can reflect part of the incoming sunlight back towards space. That means less solar energy reaches Earth's surface. The planet begins receiving less sunlight. And if the amount of sulfur injected into the atmosphere is enormous enough, the effects could spread far beyond the areas surrounding the volcanoes. The sky could become hazier, sunlight could become weaker, temperatures could begin falling. The strange part is that the planet could become colder even while thousands of volcanoes are producing enormous amounts of heat. Now the consequences begin moving from the atmosphere into the climate system. If enough sulfate aerosols remain in the upper atmosphere, global temperatures could decrease. The exact amount would depend on how much sulfur is released and how high it travels. Some regions could experience colder conditions. Growing seasons could become shorter, snow and ice could persist longer, but global cooling wouldn't happen evenly. Climate is an interconnected system. Changing the amount of sunlight reaching Earth's surface affects oceans, atmospheric circulation, clouds, and rainfall. One region might become colder and wetter. Another could become colder and drier. Weather patterns could shift far from the original volcanic eruptions, and this is where a volcanic catastrophe becomes a planetary climate problem. The next problem would be food. Modern civilization depends on predictable growing seasons. Crops need sunlight, water, suitable temperatures, and stable conditions. A sudden global climate disturbance could interfere with all of them. Some crops could suffer from colder temperatures and reduced sunlight. Other regions could experience changes in rainfall. Harvests could decline in some major agricultural areas. That wouldn't mean every crop would immediately die, but even a significant reduction in global food production could create enormous economic pressure. Food prices could rise, supply chains could become unstable. Countries could begin competing for remaining agricultural resources, and communities dependent on fishing would face another crisis as marine ecosystems respond to the changing environment. The effects of the eruptions would therefore spread far beyond the volcanoes themselves. The oceans would also experience major changes. The ocean absorbs enormous amounts of heat and interacts constantly with the atmosphere. If the atmosphere becomes darker and colder, the ocean responds too. Changes in temperature and circulation can affect marine ecosystems. But volcanic eruptions would create another problem: volcanic material entering the ocean. Near underwater volcanoes, local conditions could become extreme. At the same time, changes in sunlight could affect organisms near the surface. Phytoplankton are tiny organisms, but they are incredibly important. They form the foundation of many marine food webs. If environmental conditions change dramatically, populations could shift or decline in some regions. Fish and larger marine animals would then be affected. The ocean wouldn't simply stop functioning, but its balance could be disrupted on a massive scale. Would humanity survive? The answer is not as simple as yes or no. Humans are remarkably adaptable, and modern civilization has technology that can help us survive extreme environmental conditions. But a simultaneous eruption of every volcano would create a challenge on an unprecedented scale. Some regions would be directly threatened by eruptions, ash, lava, and volcanic gases. Other regions could be affected indirectly through food shortages, economic disruption, transportation problems, and climate changes. Air travel could become extremely difficult because volcanic ash is dangerous to aircraft engines. Roads, buildings, power systems, and water supplies could also be disrupted in heavily affected areas. Governments would have to coordinate enormous emergency responses. The world wouldn't necessarily end. But modern civilization could experience one of the greatest environmental and economic shocks in human history. Eventually, the eruptions would begin to weaken. Volcanoes would not continue erupting forever, but the end of the eruptions wouldn't mean the end of the consequences. Ash would continue settling. Atmospheric aerosols could remain long after the volcanic activity decreased. Climate patterns could take time to recover. Ecosystems would need even longer. Some landscapes would be buried under volcanic material. Other regions might experience years of unusual weather. Human societies would have to rebuild agriculture, infrastructure, transportation, and damaged ecosystems. But there is one important scientific point. This scenario is extremely unlikely. Volcanoes do not share a single global trigger that could realistically make every one of them erupt simultaneously, and not every volcano is capable of producing the same type or amount of eruption. So this is a thought experiment, a way to understand how connected Earth's atmosphere, oceans, climate, ecosystems, and civilization really are. The biggest threat wouldn't be the lava, it would be the chain reaction spreading from the ground into the atmosphere and eventually across the entire planet. One planet, thousands of volcanoes, one impossible eruption. The Earth wouldn't explode, it wouldn't become a ball of lava. The real danger would be the atmosphere, the climate, and the chain reaction that connects every part of our planet. What impossible? What if should we explore next? Subscribe. Imagine